Welcome to rotation about a horizontal and vertical line. So the general idea here is we don't have to always rotate about the X or Y axis. So we don't have to rotate about only the X or Y axis. We can actually rotate about any line. However, we will limit ourselves to horizontal and vertical lines. So in this example, we're going to find the volume of the rotational solid formed by rotating the below shaded region. Oops, it's not shaded. About the vertical line x equals 2. So this shaded region is the region enclosed by the ellipse x squared plus y squared over 4 equals 1. And we are supposed to rotate about the line x equals 2, which is the vertical line. So we are going to rotate about the vertical line x equals 2. So doing this rotation, we essentially create a like a tall donut with a hole in the middle. So doing our rotation about x equals 2, we have our ellipse to one side. We're going to mirror image that on the right. And again, we're essentially making a tall donut. So we have our donut. Our cross sections here, we were doing rotation about the vertical line. So we are going to have horizontal cross sections. Which will be washers. And our radii go from the line x equals 2 out to our graphs. So our outer radius we are going from essentially the left side of the ellipse to x equals 2. So the left side of the ellipse we'll need to find. For the left side of the ellipse, we had x squared plus y squared over 4 is equal to 1. We are going to solve for x. So we are looking at x squared is 1 minus y squared over 4. And we get that x is plus or minus the square root of 1 minus y squared over 4. So for the left side, we have the negative version. We would have x as negative the square root of 1 minus y squared over 4. So for this, we are looking at our outer radius, capital R of y, is going to be 2 minus a negative square root 1 minus y squared over 4. Or capital R of y is equal to 2 plus the square root of 1 minus y squared over 4. For our inner radius, the inner radius, we are running from the right side of the ellipse to x equals 2. So we will go from the right side of the ellipse to x equals 2. The right side of the ellipse is just the positive version, x equals positive square root of 1 minus y squared over 4. So we have that our right side, or our inner radius, is lowercase r of y is square root of, is 2 minus the square root of 1 minus y squared over 4. So anytime I've been doing my radius as blah minus 0, that's been treating it kind of as we're rotating around x equals 0 or y equals 0. And once we have our radii, we can go ahead and find our washer volume formula. So for our washer volume, we have dV is equal to pi times, in parentheses, capital R of y squared minus, in parentheses, lowercase r of y squared, and parentheses, then times dy. So we are looking at dV is equal to pi times, in parentheses, we have a 2 plus the square root of 1 minus y squared over 4, whole thing squared, and then minus a 2 minus the square root of 1 minus y squared over 4 squared, and then that entire thing times dy. Doing a little simplification, we have dV is equal to pi times, that first square becomes 4 plus 4 times the square root of 1 minus y squared over 4 plus 1 minus y squared over 4. Then we are subtracting off. That second batch becomes 4 minus 4 times the square root of 1 minus y squared over 4 plus 1 minus y squared over 4. That's just expanding out those squares. That whole thing times dy. Doing this subtraction, we have dV is equal to pi times. We have a 4 minus 4 cancel each other out. We have a plus 1 minus y squared over 4. Then we have a minus 1 plus y squared over 4. So those cancel each other out. And we are left with 4 times the square root plus another 4 times the square root. So we have dV is pi times 8 times the square root of 1 minus y squared over 4 dy. So for our volume, we are looking at a definite interval of pi times 8 square root 1 minus y squared over 4 dy. Our definite interval, we are running from the y values. The bottom of our ellipse was at -2. The top of our ellipse is at 2. So our y values are going to run from -2 to 2. So we are looking at the definite interval from -2 to 2 of pi times 8 times the square root of 1 minus y squared over 4 dy. So this becomes v is equal to 8 pi times the definite interval from -2 to 2 of the square root of 1 minus y squared over 4 dy. From here, it remains simply to apply our various integration techniques. This particular setup, having a square root of 1 minus y squared over 4, lends itself to trig substitution. So the square root of something squared minus something squared lends itself to trig substitution. So if we set up our triangle, we have the 1 minus 1 will serve as our hypotenuse. So we have our angle theta, 1 is our hypotenuse. Y squared over 4 is y over 2 squared. So we are looking at a 1 squared minus a y over 2 squared. So we will use y over 2 as our opposite. And then that square root 1 minus y squared over 4 is our adjacent. These give us the cosine of theta. Sorry, let's do sine of theta first. Sine of theta is equal to y over 2, or y is equal to 2 sine of theta. And we get then that dy is equal to 2 cosine of theta d theta. The square root 1 minus y squared over 4, that lends itself perfectly to the cosine. Cosine of theta is just the square root of 1 minus y squared over 4. So from here, we can go ahead and switch over to our integral. So doing just the indefinite interval first, we have the integral of the square root of 1 minus y squared over 4 dy. This is equal to the integral of cosine of theta times 2 cosine of theta d theta. So we are just looking at the integral of 2 cosine squared theta. I'm just going to update my screen quickly. We're looking at the integral of 2 cosine squared theta d theta. But we can go ahead and apply our power reducing. So if we power reduce, cosine squared theta was 1/2 times 1 plus cosine of 2 theta. And so 2 cosine squared theta is just 1 plus cosine of 2 theta. So we are looking at the integral of 1 plus cosine of 2 theta d theta, or integrating that, we would have theta plus 1/2 sine of 2 theta. Cosine integrates to sine. We have to counteract that times 2 in sine by dividing by 2. Then, of course, we technically have our plus c. Plugging back in, we can go sine of theta was y over 2. Cosine of theta was square root of 1 minus y squared over 4. So we have our sine of theta, or we have our our theta is just sine inverse of y over 2. Our cosine of theta being the square root of 1 minus y squared over 4. And our sine of theta being y of 2 over 2. We also have the sine of 2 theta as 2 times sine of theta times cosine of theta. So we have, this is 2 times y over 2 times the square root of 1 minus y squared over 4, or simply y times the square root of 1 minus y squared over 4. So putting this all together, we have that our integral of the square root of 1 minus y squared over 4 dy is sine inverse of y over 2. Since we had a theta, and we had plus 1/2 sine of 2 theta. So we have plus 1/2 times y times the square root of 1 minus y squared over 4. And then, of course, our plus c. So from here, we have, therefore, that our volume, which was the definite integral from -2 to 2 of the square root of 1 minus y squared over 4 dy, this is equal to sine inverse, sorry, it was actually 8 pi times this. Our volume was equal to 8 pi times this definite integral from -2 to 2 of the square root of 1 minus y squared over 4 dy. So we have 8 pi times sine inverse of y over 2 plus 1/2 y times the square root of 1 minus y squared over 4. And then we are evaluating at -2 and 2. This becomes 8 pi times sine inverse of 2 over 2 plus 2 over 2 times the square root of 1 minus 2 squared over 4. And we subtract off sine inverse of -2 over 2 plus -2 over 2 times the square root of 1 minus -2 squared over 4. And then all of that, again, was multiplied by the 8 pi out front. So just note that 1 square root 1 minus 2 squared over 4 is just the square root of 1 minus 1, or 0. So the square root of 1 minus 2 squared over 4 goes to 0. Similarly, the square root of 1 minus that -2 squared over 4 also goes to 0. So we are looking at 8 pi times sine inverse of 1 minus sine inverse of -1. Sine inverse of 1 is pi over 2. Sine inverse of -1 is a negative pi over 2. So we are looking at 8 pi times pi over 2 minus a negative pi over 2. And this is simply 8 pi squared. So that shape we were working with simply had volume 8 pi squared. Just a reminder, the shape we were looking at was the ellipse x squared plus y squared over 4 equals 1, rotated around the vertical line x equals 2, and that volume wound up simply being 8 pi squared. Right, that is the last of our discs and washers. Next, we will move on to using shells to find volume.